Imagine the vast, dark expanse of space stretching out in every direction, an endless ocean of nothingness punctuated by the faint glimmer of distant stars. Unfathomably huge, a scale so immense it defies human comprehension. It's a place where distances are measured in light years and where the very fabric of reality seems to bend and warp. Now, picture a single grain of sand, seemingly insignificant, almost invisible to the naked eye, flinging across millions of miles, traversing the interplanetary gulf, a lonely traveler in the cosmic sea. Moving at incredible speeds, a blur of motion against the backdrop of the cosmos, a testament to the immense forces at play in the universe. This is our cosmic needle, a small, distant asteroid, a tiny speck of rock and metal adrift in the vastness of space. Finding it is a monumental task. Hitting that target is another challenge altogether, a feat of engineering and navigation that pushes the boundaries of what's possible. It demands pinpoint precision, a level of accuracy that seems almost impossible to achieve across such vast distances. Calculations must be perfect, every variable accounted for, every potential error meticulously corrected. There is no room for error. A tiny miscalculation means failure, a missed opportunity, and years of work potentially wasted. The spacecraft travels for years, enduring the harsh conditions of space, a silent sentinel on a long and lonely journey. Through the cold, unforgiving void, where temperatures plummet to absolute zero and radiation bombards every surface, guided by human ingenuity, a testament to our relentless pursuit of knowledge and our unwavering belief in the power of technology. Reaching for a speck of dust, this is not science fiction, this is the culmination of decades of research and development. This is real. This is the tangible result of human curiosity and determination. This is happening now as we speak, pushing the boundaries of our understanding of the universe and our place within it. China has embarked on this journey, joining the ranks of nations that dare to dream big and reach for the stars. A mission of incredible daring, a bold undertaking that will test the limits of their technological capabilities. To touch an asteroid, to make contact with a celestial body millions of miles away, and bring a piece of it home, a fragment of the cosmos to study and analyze, unlocking secrets about the formation of our solar system. It tests the limits of our reach, pushing the boundaries of what we thought was possible in space exploration, and pushes the boundaries of exploration, opening up new frontiers and inspiring future generations of scientists and engineers. A testament to human ambition, our insatiable curiosity, and our unwavering desire to explore the unknown. Think of the scale Earth, a blue marble, a fragile oasis of life in the vast emptiness of space. The asteroid, a mere pebble, a tiny fragment of rock and metal, yet holding clues to the origins of our solar system. Separated by cosmic distances, an unimaginable gulf of space that dwarfs our understanding of scale. Yet we dare to bridge that gap, with robots, with intelligence, with the most advanced technology we can muster. With an unyielding quest to know, to understand, to unravel the mysteries of the universe and our place within it. This is more than a mission. It is a statement, a declaration of our ambition, our ingenuity, and our unwavering spirit of exploration. The universe is within our grasp, and we are reaching out to claim it, one asteroid, one mission, one discovery at a time. This ambitious endeavor has been given a significant name, Tianwen-2, which translates to questions to heaven. It reflects the profound curiosity driving this mission, a fitting title indeed for such a bold and unprecedented quest into the depths of our solar system. Spearheaded by China's National Space Administration, or CNSA, this mission is reaching far beyond our familiar planetary neighbors, venturing deep into the solar system's unknown territories. Their primary target, a rather special asteroid designated 2016 HO3, but also affectionately known as Kamo-o-alewa, a Hawaiian word, and it's a tiny quasi-satellite, a companion to Earth. So, what exactly will Tianwen-2 do on this daring mission? Its goals are not only ambitious, but also scientifically groundbreaking. First and foremost, it must successfully navigate the vast expanse of space to reach Kamo-o-alewa, a near-Earth asteroid that's only about 40 meters across, making it a relatively small target. Then, the spacecraft will embark on an even more challenging endeavor. It will attempt to land, a delicate and potentially dangerous maneuver, especially considering the asteroid's extremely low gravity gravity, it must anchor itself securely to the asteroid's surface, firmly attaching itself to this ancient piece of rock, a relic from the early solar system. Once safely on the surface, the real work begins. Drilling into the asteroid's surface, carefully scooping up samples, collecting both dust and rock from its surface, and also from just beneath the surface. These precious fragments, potentially holding secrets of the early solar system, will be carefully stored and sealed within a specialized capsule, ready for the long journey back to Earth. But the mission doesn't simply end there with the sample return. After successfully sending the asteroid samples home, the main spacecraft will embark on yet another task, undertaking a grand detour to visit a main belt comet, adding another layer of complexity to this mission, specifically, Comet 39 Pioterma. Studying two distinct celestial bodies in a single truly remarkable mission, it's an ambitious undertaking. With Tianwen-2, China is aiming high, pushing the boundaries of space exploration. Asteroids, those silent wanderers of the solar system, hold ancient secrets, waiting to be unlocked. They are relics from a bygone era. Why all this effort to reach out and touch these celestial bodies? What drives our insatiable curiosity? Asteroids are not just barren stones, lifeless chunks of rock drifting through the void. They are time capsules frozen in the infancy of our solar system. They hold invaluable clues about our solar system's birth and evolution, offering a glimpse into the processes that shape the planets we know today. Formed billions of years ago in the swirling chaos of the early solar nebula, they are leftover building blocks of planets, remnants of a construction project never fully completed. Studying them is like reading history written in the language of space, deciphering the story of our cosmic origins. These space rocks may harbor secrets about the origins of life, the very ingredients that sparked existence on Earth. Scientists believe asteroids delivered water and organic molecules to a young Earth, seeding our planet with the building blocks of life. By analyzing asteroid samples with cutting-edge technology, we can test these theories, pushing the boundaries of our understanding, and learn about our own beginnings, tracing our roots back to the very formation of our planet and the potential for life elsewhere, expanding our search for habitable worlds beyond our solar system. Asteroids are also treasure chests, glittering with the promise of untold riches, containing valuable minerals, resources that could revolutionize our future in space. Iron, nickel and cobalt, even platinum and gold, all waiting to be extracted. These resources are finite on Earth, our planet's reserves are dwindling. Asteroids could one day be mined, offering a sustainable solution to our resource needs, providing materials for future generations, ensuring a prosperous future for humanity among the stars, or construction in space, enabling us to build vast orbital habitats and explore the cosmos. Beyond science and resources, beyond the allure of discovery and wealth, asteroids pose a potential threat, a cosmic sword of Damocles hanging over our heads. Large ones have hit Earth before, leaving scars on our planet's surface with devastating consequences, reshaping the course of life on Earth. Understanding their composition, structure, the very essence of these celestial wanderers and orbits is crucial for planetary defense, safeguarding our planet from potential impacts. Missions like Tianwen-2 help us learn how to protect our world, developing the technologies and strategies we need to deflect any future threats. Knowledge is our best shield, the key to ensuring the survival of our species. Returning samples from an asteroid is an incredibly difficult feat. Only a few nations have achieved it. An exclusive club. Japan was the pioneer with its Hayabusa mission, bringing back tiny grains from asteroid Itokawa in 2010. Then came Hayabusa 2, collecting samples from Ryugu and returning them in 2020, even deploying small rovers for stunning images and data. The United States followed with OSIRIS-REx, collecting a large sample from Bennu, returned in 2023. Now China aims to join this elite group with Tianwen-2. This is a matter of national pride and a demonstration of capability. China's space program has grown rapidly, catching up with established powers. Successfully returning asteroid samples would be a major milestone, cementing China's status as a leading spacefaring nation. China is not just aiming to join, it often aims to surpass. Tianwen-2 has unique aspects, targeting a very small asteroid, Kamuawalawa, a quasi-satellite of Earth. And the planned comet flyby adds another layer of complexity and scientific return. China is pushing its own limits. How will Tianwen-2 achieve its goals? Through incredible engineering. The spacecraft is designed for a long, lonely journey and delicate operations millions of miles from home. It carries a suite of instruments to study Kamowalewa up close before attempting to touch it. The lander must gently descend to the asteroid's irregular surface, using anchors or thrusters to stay put. Once stable, a robotic arm deploys, crucial for drilling and scooping. It can collect samples in two ways: a quick touch and go for surface material, and drilling up to a meter deep. After collection, samples are sealed inside a special return capsule built to survive fiery re-entry. The main spacecraft then releases the capsule and heads for the comet. This double-duty design increases the mission's complexity. Tianwen-2 is not an isolated mission. It's part of a grander vision: China's vast ambitions in space. This asteroid mission is a key step in a long-term strategic plan. China's lunar program is already well known, with the Chang'e missions landing on the moon, returning samples, and exploring the far side. Now, China plans to build a lunar base, collaborating with other countries. The moon is seen as a stepping stone for deeper space exploration. Mars is also in China's sights. Tianwen-1 sent an orbiter, lander, and rover to Mars on its first attempt. Future Mars missions, including sample returns, are planned. These missions serve scientific discovery, technological advancement, and national prestige. Success in space is a powerful symbol, inspiring people and influencing global space policies. Every space mission is risky, but Tianwen-2 faces unique dangers. The target, Kamowalewa, is tiny, only about 40 to 100 meters wide. Imagine trying to land on a pebble tumbling through space, possibly spinning rapidly. The asteroid's surface is unknown. Boulders or shifting dust could await. The lander must cope without direct human control. Communication signals take minutes to travel. The spacecraft must operate autonomously, making its own decisions. Technical challenges abound. The drilling mechanism could fail. The robotic arm could get stuck. The return capsule could malfunction. Space is unforgiving. Extreme temperatures, radiation, micrometeoroid impacts. Years of work could be lost. The possibility of failure is always present. Engineers and scientists design robust systems, but the universe often has surprises. The thrill of exploration comes with the acceptance of risk. The world will watch, holding its breath. What if Tianwen-2 succeeds? The rewards would be immense. Scientifically, the samples would be invaluable. Material from a quasi-satellite never sampled before. It could rewrite our understanding of asteroid formation and their relationship with Earth. Clues about water and life could be hidden in those tiny grains. Success would boost China's global standing and inspire a new generation. The mission could ignite an asteroid gold rush, accelerating interest in space mining. A successful Tianwen-2 could usher in a new era of space resource utilization, transforming our future. The universe watches. Will Tianwen-2 achieve its goals, or will the harshness of space claim another venture? This mission is a bold gamble, a leap into the unknown. Whatever the outcome, Tianwen-2 is already significant. It highlights a changing landscape in space exploration. The new space race is here. Many nations and private companies are involved. Destinations are more diverse: the moon, Mars, asteroids, and beyond. This mission raises profound questions. What is humanity's future in space? Missions like Tianwen-2 embody our curiosity and drive to push boundaries. The success or failure will shape future missions and influence international collaborations. The journey of this small spacecraft is a reflection of our own journey as a species reaching for the stars. The next chapter is being written now.